They found that certain species were very strongly associated with specific depths and distances from the glacier. For example, at 5 meters deep, near the glacier, they found tons of this one amphipod species.
Amphipods.
Yeah, they're these tiny crustaceans, little critters that are a super important part of the food web. This particular one was called Eurimera monticulosa. But as you moved away from the glacier, even at that same depth, you started to see fewer of them, and other species became more common.
So it's like a constantly shifting mosaic of life, with different species dominating depending on how deep you are and how close you are to the glacier. And as that glacier keeps melting, I bet that mosaic is going to keep changing too, right?
Exactly. This study gives us a snapshot of the ecosystem right now, but it raises some big questions about what's going to happen to these communities as climate change keeps accelerating glacier melt.
Right. Like, will those species be able to adapt? Will new species move in? Could we see the whole ecosystem restructure itself? What about the species that are only found in these unique Antarctic environments? Could we lose them forever?
Those are all critical questions, and the answers have some pretty significant consequences. This research really highlights how delicately balanced these ecosystems are and the ripple effects of a changing climate. Though, it seems like the seaweed might be proving a bit more resilient than the invertebrates, at least in some cases.
Yeah, that's true. The study did find that the impact on the seaweed communities was a bit more complex. Some species definitely took a hit, especially from all that sedimentation, but others seem to be doing okay, maybe even benefiting from the changes. I'm still trying to wrap my head around the impact on seaweed. If some species actually thrive in those disturbed areas, wouldn't that mean overall diversity increases?
Well, you have to remember, it's not just about the number of species, but also the types of species.
Right, the composition matters.
Exactly. Those tough pioneer species might flourish in disturbed areas, but they often replace the species that are adapted to more stable conditions, the specialists.
Oh, I see. So you could have the same number of species, but the community is fundamentally different.
Precisely. So it's not just about losing species altogether. It's also about losing the unique character of these communities as they adjust to a changing environment. It's like, imagine you have a beautiful tapestry with all these intricate details and vibrant colors. Now imagine some of those threads start to fray and get replaced with different ones. The tapestry might still be there, but it's lost some of its original beauty and complexity.
That's a really powerful analogy. It's not just about the presence or absence of life, but about the richness and the uniqueness of that life. Speaking of complexity, the paper mentioned that there are probably other factors influencing seaweed diversity beyond just sedimentation and turbidity, right?
Oh yeah, for sure. Things like nutrient availability, the water temperature, and grazing pressure from animals all play a role.
Grazing pressure.
Yeah, like how much the seaweed is being munched on by things like sea urchins or fish. Seaweed communities are shaped by this whole web of interactions, and understanding all those connections is crucial to predicting how they'll respond to future changes.
It sounds like a giant multidimensional puzzle. We've talked about sedimentation and ice scouring, but what about those other factors you mentioned? How might they be affected by the glacier melt?
Well, glacier melt can influence all of them. For example, as glaciers melt, they release nutrients into the water, which can shift the balance of nutrients in the ecosystem.
Oh, right, like fertilizer runoff.
Kind of, yeah. And changes in water temperature can also affect how well seaweed grows and survives. Plus, the mix of grazers, like those sea urchins and fish, can change as the environment changes, leading to different levels of munching on different seaweed species.
So it's not just the direct physical impacts of the glacier melt, but these indirect effects as well, creating this cascade of changes throughout the ecosystem. It's like a domino effect. The researchers also mentioned that there are likely other factors at play that they couldn't directly measure, right?
Absolutely. There are always limitations to any study, and this one was no exception. They couldn't measure everything, so there might be other things influencing those patterns that we're just not aware of yet. That's why it's so important to keep researching these systems, to get a more complete picture.
It seems like we've already uncovered a whole lot of complexity, though. Melting glaciers, sedimentation, changing light conditions, ice scouring, nutrient availability, temperature shifts, grazing pressure. It's a lot for these Antarctic communities to deal with. But hasn't this research also pointed to some potential resilience in these ecosystems?
That's a great point. Even with all these dramatic changes, there are signs that these communities can adapt and bounce back. Remember that seaweed species, Palmaria decipiens, that seem to be thriving in those disturbed areas near the glacier?
Yeah, the pioneer species. It's like they're the first responders rushing in to colonize those newly available habitats. Maybe they even pave the way for other species to follow.
Exactly. And it's not just those pioneers. Other organisms might have adaptations or behaviors that help them cope with the changing conditions. Some seaweed species might be able to handle those lower light levels or higher sedimentation better than others. Some invertebrates might burrow deeper into the sediment or switch up their feeding strategies.
So even though some species might struggle, others might find ways to survive and even thrive in this new environment. It's amazing how life adapts.
It is. But the big question is, will that adaptation lead to a stable and diverse ecosystem in the long run? To figure that out, we need to understand not only which species can survive, but how those shifts in the community structure affect how the whole ecosystem functions.
Because a resilient ecosystem isn't just about individual species hanging on, it's about those intricate relationships between species and their environment staying intact.
Exactly.
So what happens in Fields Bay doesn't just stay in Fields Bay, right?
Yeah.
What we're seeing in this one little spot in Antarctica is actually a microcosm of these larger changes happening all over the planet.
Absolutely. The same forces that are impacting this ecosystem are impacting other glacial environments around the world. And the consequences of those changes will be felt far beyond those icy landscapes.
So this brings up a really important question. Why should you, sitting at home, care about what's happening in this remote bay in Antarctica? What does all this have to do with us beyond those penguins and seals?
That is the million-dollar question, isn't it? Like, why should we care about what's happening in a place as far away as Antarctica? It feels like another world.
Yeah.
You know?
It's easy to feel disconnected from those icy landscapes.
Yeah, but even though Antarctica seems remote, those changes happening down there actually have ripple effects that reach every corner of our planet. I mean, the polar regions play a huge role in regulating Earth's climate, and what happens there affects us all, whether we realize it or not.
So this isn't just about penguins and seals. We're talking about consequences that could impact everyone, everywhere.
Exactly, like those melting glaciers are a big contributor to rising sea levels, which puts coastal communities all over the world at risk. And the shifts in ocean circulation patterns, those can disrupt weather systems and fisheries too. It's all connected, you know?
Okay, yeah, that definitely makes the stakes a lot clearer. But it also feels kind of overwhelming, Like, what can we even do about a problem this massive?
I get that. It's easy to feel powerless when you're facing something this big, but I think it's so important to remember that knowledge is power. The more we understand about these complex systems, the better equipped we are to make informed decisions and take action.
So you're saying that learning about things like glacier melt and biodiversity loss isn't just about, expanding our minds. It's about giving us the tools to be part of the solution.
Exactly. We can all make choices in our daily lives to reduce our carbon footprint. We can support policies that promote sustainability and renewable energy. And we can get behind the research that's helping us understand and address these challenges. Every little bit helps.
So it's about a multi-pronged approach. Individual action, policy changes, and scientific advancement all working together.
Precisely. And let's not forget the power of spreading awareness. The more people who understand what's at stake, the more we can push for real change.
That's where you come in, dear listener. This deep dive has hopefully shed some light on this amazing and fragile world of Antarctic marine life and the impacts of climate change. But it's not just about knowing the facts, it's about what you do with them.
Yeah, take what you've learned, share it with your friends and family, start conversations, ask questions, challenge assumptions, be a voice for change.
And if you want to learn more, we've included a link to the original research paper in the show notes. We'd love to hear your thoughts on this episode too. What resonated with you? What questions are still swirling around in your head? Connect with us on social media or send us a message. We're always up for good conversation.
And as we wrap up this deep dive, I want to leave you with one last thought to ponder. This study focused on the creatures we can see in Fields Bay, the seaweed and the invertebrates, but what about the invisible world? The tiny organisms, like bacteria and phytoplankton that form the base of the food web. How are they being affected by these changes? And what does that mean for the entire ecosystem? Those are questions that scientists are actively exploring, and the answers are bound to reveal even more about how interconnected our planet really is and the impact we have on it.
It's a great reminder that there's always more to learn, more to discover, and more to do. So stay curious, keep exploring, and let's all work together to create a brighter, more sustainable future for everyone. Until next time,